This video discusses parallel and perpendicular lines. Two lines in the same plane are parallel if they do not intersect. It is a fact that parallel lines have the same slope. This is how they don't intersect. They're either increasing or decreasing at exactly the same rate. Two lines that intersect at a right angle are perpendicular. It is a fact that perpendicular lines have slopes that are opposite reciprocals of each other. So that means the opposite sign and flip over the fraction. In algebra, to determine whether lines are parallel, perpendicular, or neither, you want to directly compare the slopes. If they're exactly the same, the lines are parallel. If they're opposite reciprocals of each other, the lines are perpendicular. If it's not either one of those two very specific cases, then it's neither parallel nor perpendicular. So let's determine whether the lines passing through the given points are parallel, perpendicular, or neither. The only way to do this in algebra is to directly compare the slopes. So first thing we need to do is figure out the slopes for each of the lines. Starting with the first one. And remember, when finding slope between two given points, we're using our slope formula, y2 minus y1 over x2 minus x1. The slope here for this first one, 6 minus 2 over 6 minus 4. It's going to be 4 over 2, which is positive 2. And I just use that subscript notation here to indicate that it's the first line. You wouldn't have to, but I like to just so I don't, get confused in my own work. And now we need to find the slope between these two given points. We have our second slope here is going to be 0 minus negative 2 over 1 minus 0. So it's 0 plus 2 over 1. 2 over 1 is 2. Now it's time to directly compare the slopes. This one's positive 2. This one's positive 2. Same slopes. Tell us that these lines have to be parallel. Let's try another one. Again, we want to determine whether the given lines are parallel, perpendicular, or neither. But if you look at what we're given this time, it's different. What we need to do, directly compare the slope, stays the same, but since we are given equations of lines instead of sets of points, the way that we find the slope for each of these is to rewrite the equation in slope-intercept form, y equals mx plus b. Then we just look at the m and compare. Starting with our first equation, we need to isolate the y. We'll subtract x from both sides. Negative 4y equals negative x plus 2. Next, we divide by negative 4. And you want to be sure to divide each term individually when you're doing this, rather than, like a big divided by negative 4 over here. You don't want to do that. This gives us y equals, now here we have a negative divided by a negative. I know my answer is going to be positive. But rather than writing this x over 4, I want to be able to clearly see the coefficient of x, which would be our slope. We know there's a 1 up here with the x. So instead, let's write that 1/4 x. And then a positive divided by a negative, that's going to be minus 1/2. Now that we have it in slope-intercept form, we can identify the slope. It's going to be our b value, which is the coefficient of x. Now we'll do the other equation. Solving for y, we'll subtract 4x from both sides. We get y equals negative 4x plus 8. Now that our equation is in slope-intercept form, we identify the slope by just looking at the coefficient of x. Our second slope is negative 4. Well, now let's compare. Our first slope is positive 1/4. Our second slope is negative 4. These slopes are opposite reciprocals. It may help to put the whole number over 1 to see that it is in fact the reciprocal. Since we have opposite reciprocals, this tells us that these two lines are perpendicular. Next, we're going to write equations of a line that are either parallel or perpendicular to another line. So let's write the equation of the line that contains the point 3, 1 and is perpendicular to the line y equals negative 2x plus 5. Recall, in order to write the equation of a line, you need two things. You need the slope of the line you're trying to write the equation of and a point that lies on that line. Well, they already gave us the point. But what we need is the slope. They did not explicitly give us the slope, but they told us that the line we're writing the equation for is perpendicular to this line. So that means that the slope that we want to use is going to be the opposite reciprocal of this line. And we need to start by identifying the slope of this line. To do so, you put it in slope-intercept form. It already is, so that's nice. The slope of this line is negative 2, but that is not the slope that we want to use. We want to be perpendicular to this line. The slope that would be perpendicular to negative 2 is positive 1/2. Again, this subscript is kind of my own little made-up notation that makes sure that I've actually thought about the fact that my line is perpendicular to this line and how that affects the slope. Also, if I have two m's written on my paper, I may not remember as I'm plugging numbers in, writing the equation, which one to use. So that's why I like to use this little subscript here of m with a little symbol there. That upside down T means perpendicular because it looks like there's a right angle right here. Okay. So we're writing the equation of a line that has the slope 1/2 and passes through the point 3, 1. I'm going to use y equals mx plus b to write the equation of the line this time. We're going to plug in x, y, and m, solve for b. 1 equals 1/2 times 3 plus b. So that's 1 equals 3/2 plus b. Subtracting 3/2 from both sides, I get negative 1/2 to be my b. To write the equation of a line, all we need to do now is plug the b that we just found and our perpendicular slope into y equals mx plus b. We get y equals negative 1/2 x. Oh, positive 1/2. Sorry. Y equals a positive 1/2 x minus 1/2. In our final example, we want to write the equation of a line that contains the point 2, 1 and is parallel to the line 3x plus y equals negative 1. In order to write the equation of our line, we need a point, which is given, and a slope. They don't directly give us the slope, but they tell us that our line is parallel to the line 3x plus y equals negative 1. That tells us that we want the same slope as this equation right here. So the first thing we need to do is find the slope of this equation. It needs to be put in y equals mx plus b, slope-intercept form, to identify the slope. To solve for y, we'll subtract 3x from both sides. Y equals negative 3x minus 1. The slope of this line is negative 3. Our line is parallel to this line, so we want to use the same slope. Our parallel slope, negative 3, and we need to pass through the point 2, 1. I'm going to use point slope form of a line this time. Y minus 1 equals negative 3 times x minus 2. Distributing the negative 3, we get y minus 1 equals negative 3x plus 6. And lastly, we'll add 1 to both sides. We get y equals negative 3x plus 7.